Yeah, hello and welcome to the master solution of assignment 1 for the domain-specific modeling course held at University of Höfte. My name is Manfred Joisfeld, and I am introducing to this master solution using the ConceptBase system. So the assignment was to define some core concepts of the iStar language, a goal modeling language or social modeling language developed by Eric Yu and others. The specification of the iStar language is available at various places. For example, these are good entry points for the iStar language. So part 1 of the assignment is to define the iStar language itself. Part 2 is to define some analysis queries. The first one is to return those actors that do not depend on other actors, but other actors depend on these. Let's call them independent actors, those actors that fulfill this condition. Then question 2 is to return those goals that are not contributing to other goals, so they are top goals, but all the leaf things, the leaf goals or tasks are tasks. And finally, find cycles in a goal hierarchy, which obviously is a mistake. If we have a hierarchy, then there should not be a cycle. Finally, the third part is to provide examples to show that the queries work as expected. Good, so let's start with a master solution. The first part is a so-called notation definition level, or M3 level, which are the basic constructs to define a modeling language like iStar. So we have a graphical representation of this using the ConceptBase graph browser, and we use this rather generic notation definition level where we have nodes and we have links, and both of them are subsumed by the concept node or link, and every node or link can have a link itself or connection to a node or a link. Then we have the most generic telos object proposition, and we shall define a generic relation called transitive, or we have defined that here. So this is just a graphical view. Let's have a look at the at all the definitions, sorry. So that is the content of this notation definition level, which we put in a module NDL. So use the module system here of ConceptBase, NDL. So here we have the definition of the transitive relation, and it's defined by a rule, namely this one here. Let's make it a little bit bigger. So that's a rule here. The important part is this part. If x is related to y and y to z, then x is related to z. That's the transitivity. The rest is providing ranges for the variables. So they range over some classes. It's a generic formula because the class itself is a variable. So it's a very generic definition of transitivity. We will use that subsequently in our solution. Good, then let's scroll a little bit down. There are some definitions like defining a relation to be the inverse of another relation. Attribute stands both for attributes and relations. We don't use it here. Then this is a definition of our nodes and node or links. So that's a textual definition of what we saw graphically. Further, this notation definition module contains some graphical palettes which make the display more user-friendly and actually more close to the iStar notation. Not 100% close, but close to the iStar notation. You can have a look in the source files of the master solution to see more details. Good, so that is the notation definition level. So let's now see part A of the master solution. That is the definition of the construct of the core constructs of iStar in the notation definition level. So we use here iStar element as the most generic iStar element, and the rest is a subclass of that. One possible iStar element is actor. Let's see whether we have some subclasses here. Yeah, indeed we have some subclasses here. Let's remove this one here. So position and role are subclasses here. Further, we have dependum, which we interpret as a superclass of goal and task. So something that actors can depend on. So we have the depender, that is the actor that depends on the goal or the task, and the dependee is kind of the provider of the fulfillment of the goal or the execution of a task. It's a bit simplified from the original meta model of iStar. Further, we have refinement, so we can refine goals and tasks either by an AND refinement or by an OR refinement. In an AND refinement, all sub-goals or sub-tasks have to be present. In an OR refinement, it's sufficient if one of the sub-goals or sub-tasks is present or fulfilled. Finally, we have some things like quality that qualifies a resource, and a resource is needed by a task. So that's taken from the meta model of iStar. Sorry, I messed it up a little bit here. You see that further we have goals, special types of goals that are soft goals that are goals that are depending on the behavior of actors, I believe, or not so easy to measure these goals, the fulfillment of these goals. So that is the M2 model of iStar, the notation definition, the notation of iStar in ConceptBase. So let's have a look at the textual representation of this. Make it bigger again, and then you see here we have iStar element, actors, age and position. We have dependum, quality, and here are some attributes of dependum, soft goal, refinement, and refinement or refinement. Then we have actor depends on actor. That is a derived relation. We derive that by a rule, by this rule. So if we have a dependum that is between two actors, and we have a dependee A2 and a depender A1, then A1 depends on A2. So we map the dependency between two actors via a dependum to a binary relation depends on. And then you see here how we use a transitivity. By making the depends on appear under the attribute category transitive, we automatically make it transitive. So let's have a look at the full definition of actor. Then you see that there's a rule generated from our generic definition of transitivity, and there what used to be a variable for the class is now the class that we are talking about. So the depends on is defined as transitive, then the source and destination of this relation is both actor, and that was a class C in the original definition of the transitivity rule, and that is the specialized rules for dependency. That's exactly the transitivity rule for depends on, and this gives you the base solution. The first rule gives you the base solution for this binary relation depends on. Good, so let's go back to the full definition to see whether we have some more here. That is the definition of the first query, independent actor. That is an actor that doesn't depend on any other actor, so there's no other actor that such that this actor depends on the other actor A1, but some other actor A2 depends on our actor this. That stands for any solution to this query. So that is all we need. So the work is actually done by the transitivity here, and we use that to define the query. Note that there may be transitive dependencies between actors via many dependums. Let's go further. If we have a dependum, which is either a goal or a task, then if one goal is or one dependum is refined to another dependum, then the other dependum, like G1, contributes to these dependum G2. So G2 is more a top level, at a higher level, and G1 contributes to G2. Oh, that's another rule for dependum. Let's have a look at contributes to, and indeed we also make this transitive. So that's the rule for transitivity that is generated. You don't have to write it yourself. That's the compiler that does that. But we see here what the compiler has done. So this is mapping the refinements between goals and tasks to a binary relation contributes to between dependums. That makes it easier to analyze goal and task hierarchies. Let's go back to what we have. So yeah, so now we go to the second part of the B part, the query for top goals, where all the decomposed leaves are ultimately tasks. So a top goal is a goal that is not contribute to a refinement of an upper level goal. So it is at the top of the hierarchy, of the refinement hierarchy. That is this definition. That's defined as a query. So it's any goal that fulfills this condition here. Then top goals that where all the leaves are tasks. That is let me see. That is using another auxiliary query that is a leaf dependum. That is a leaf dependum is a goal or a task that is not further refined. So it's kind of a leaf node. So let's go back to the definition of top goal. That's here. So then we can formulate our solution for the second query. Top goals where all the leaves are task is any top goal where all leaf dependums contribute. If that contributes to this top goal, then this thing here must be a task. So that means all the leaf goals of this top goal are tasks. Good. The third query are cyclic goals. And we could simply say a cyclic goal is a goal where this contributes to this, but well, we might have reflexivity of goals. So each goal contributes to itself. So here's a slightly more complicated definition of a cycle. It's a goal that contributes to some dependum D, and D contributes to this goal. So there's another a dependum here in the middle. That's a cycle. Good. That's the whole definition of part A and B, including the queries. So now let's look at the examples that highlight what the queries do. Example 1, that is about independent actors, I believe. So an independent actor is an actor like A2 that is not needed, or where no other actor depends on this. So this person doesn't depend on any other person. That's an independent actor, but there is another actor, at least one here, like A2, that depends on our independent actor. So this is an instance of actor. So this A4 here is another actor. It doesn't depend on anybody else, but also there is nobody that depends on this. So that doesn't qualify it for our condition that we formulated for independent actor. So let's have a look. That's the second part here of this definition. Good. So this uses these graphical types that we defined at our notation definition level. I can show the graph type of this one here. That is a soft goal, and if we display this, you see how soft goal are represented, a rather complicated polygon shape. Let's take a more simple one like this. Actor, outgoing attribute, the graph type of this here is actor GT, and actor GT is some kind of a circle. So it's a circle in a greenish color, and all actors will be displayed in this way. Okay, so this is only for having a rather nice representation. Let's close this, and also close this one, and go to example 2. That is the top goals where all the leaf goals are tasks. So goal 1 is a top goal, and you see it's refined to task T1 and T2 plus a goal G2, which is itself refined to task T3 and T4. This happens to be an AND refinement, but could also have been an OR refinement. This G3 is also refined into task T5, but this one here is also a leaf node, but it's not a task. So G3 is not a top goal where all the leaf goals are tasks. So that is the second query, the example for the second query. Let's close that and go to the last example, that was cyclic refinement. So here G2 is refined via this refinement to G3, but G3 is refined to G4. So G4 is refined to G3, and G3 is refined to G4. that is a cycle in the refinement hierarchy, which should be avoided, and that's our cyclic goal query that we talked about before. So with having transitivity, this is relatively easy. This is not using the transitivity, but you can imagine this could go via a long path to some sub-goals, and that could go back. So this by having the transitivity, this query will find all the cycles regardless how deep the hierarchy is. Yeah, that's the master solution of assignment 2. I hope you enjoyed the presentation. The sources and also the graph files will be provided via our learning environment, so via the CU system. Thank you very much, and bye-bye.